All right, so here's your exam prep continued, starting with number 40. Now to the graphing questions and the function questions like that. So could you graph this? 2 sine x subtract 5. So what's the amplitude? It's in front, it's 2. The period, there's nothing inside multiplying, so it stays 2 pi. And then negative 5 means there's a vertical shift down 5 that we need to be aware of. So it would be helpful to understand the max of the wave would have been 2, but we're going to subtract 5, so now it's negative 3. The middle of the wave is at negative 5, and then the bottom of the wave is at negative 7. So these are the y values that I need to be aware of with my pattern. So sine starts in the middle, and that means at 2 pi it ends in the middle. And then in the middle is a third middle point. Because it's positive, it's going to go up to the maximum. Oh, what am I doing? So where is our middle? At negative 5. So let's start here at negative 5. So let me take out my eraser and make sure that I do it correctly for you. Like it never happened. I should just start the video over again, but I won't. Mistakes happen. So when I looked, I realized the max is at negative 3, so I did something wrong with the middle. That's how I corrected myself. So at negative 5, and at 2 pi would be at negative 5, and in the middle at negative 5. So negative 5 is in the middle of it. Then from there, it goes to the maximum, and it goes to the minimum. So think of negative 7 down here. And there's your pattern that you're going to follow. Can you go the other direction? Can you write a sine function that has this amplitude and this period? So the amplitude would be in front, and then inside the period we're going to go, so if we want the period to be 3 pi, if I want it to be that, remember that you go times the reciprocal to get your answer. Oh, what did I do wrong? 2 pi over 3 pi. So if I want to put it inside my function, I need to go 2 pi over whatever the period is. That's what's going to go inside. Now I could simplify that. So that's just 2/3 x. So this function has an amplitude of 5, and if you found the period, so notice to find the period you go 2 pi and then undo it, recognize it would give you the period that you need. So recognize this to be able to write the function down properly. All right. 42. So the amplitude here is 5. The period is still 2 pi, and the phase shift's negative pi over 2. So I'm going to start here at negative pi over 2. There's no vertical shifts at all, so I can just go right to what I need to go to. So positive 5. So at negative pi over 2, find positive 5. There's the top of your wave. Then go 2 pi to the right. And in this example, that's counting 4 tick marks. 1, 2, 3, 4. That's the end of the cycle. And then go 2 to the left, or in the middle, and then the bottom of the wave, which is at negative 5. And then you find the middle of your wave, and then you have your pattern. So now I'm just going to follow the pattern all the way through, and then draw my wave. (43) Can you graph this? Well, this has an amplitude of 2. The period was 2 pi, but we're going to divide it by 2, so now it's pi. So no phase shift. So this starts at the bottom. Because of the negative there, it's going to start at negative 2. And then at pi, we'll end the cycle. In between that, at pi over 2, we go to the top, which is at 2. And then in the middle will be the middle of the wave. So I'm going to follow that pattern across and then draw my wave. Here's an equation, and we need to write an equation for this. So I can see the top of the wave is 5. If I continue it, I'm pretty sure the bottom of the wave is -5. So I can be pretty confident that the amplitude is 5. It didn't say write a sine, so I can just write cosine and not worry about a phase shift. So I know it's cosine because it starts at the top of the wave. So already I have this part. The only part that I need is inside, what am I going to multiply it times? So whatever the period is, I'm going to go 2 pi divided by that. So how long does it take to get to the bottom, and what's our period here? So one way is to try to understand top, middle, bottom, how long it takes. So if I look at this from bottom to bottom, it's hard to tell, isn't it? I'm going to just assume that from bottom to bottom, here to here, that distance for like one cycle from the bottom of the wave to the bottom of the wave is 4 pi. So if that's true, and I divide by 4 pi and simplify it, then this answer would just be 1/2 x. It's in the page. Let's try this one. This one might be more obvious in terms of what we're looking for. So what am I looking for? It starts in the middle, so it's sine. What's the amplitude? 4 to -4. So the amplitude's 4. And I'm not going to do a phase shift, but I need to know the period. So how long does it take to complete one cycle? So up, then down, then back again, it's pi. So I'm going to take 2 pi and divide it by pi. And that gives me the number inside. And this equation matches this wave. All right, one more time. So this starts in the middle and goes up. So it's going to be sine. The top is at 3, the bottom's at -3, so the amplitude is 3. Now I need to know the period of the function. So I have from here to here, thinking what is that distance? How many tick marks is that? 1, 2, 3, 4. And then you think through, okay, what's each tick mark worth? And so we have, this is pi over 2. So from negative pi over 2 to positive pi over 2. Or each tick mark is pi over 4. So if I counted over the tick marks, 1 pi would be one cycle. Kind of like from -1/2 to +1/2, what distance is that? And it's 1. So it's 1 pi. So we're going to go 2 pi divided by 1 pi. And that answer is just 2. So the equation of that is y equals 3 sine 2x. All right, again, write the equation. So what's the equation here? So it has to be a sine function. So the amplitude is 5. The period is 3 pi. So we're going to go 2 pi over 3 pi. And then the phase shift, I go in the opposite direction. So it's going to be adding pi over 3. And yes, you could simplify this down to just 2/3. Let's do it again. The amplitude is 4. The period's pi. So I'm going to go 2 pi divided by pi. X plus 3. And then yes, the pi's divide out, so it could just be 2 in front. Here's one where you're solving an equation. So to solve this equation, we're going to get sine by itself. So step 1, I'm going to subtract 1. That's -1/2. And then I'm going to divide by -1, so that sine theta is equal to +1/2. So I need to know what's the reference angle when the y coordinate's 1/2. So that's 30 degrees. The radian is over 6. What quadrant are we in? So all students take calculus. This is when sine is +1/2. So what quadrants is sine positive in? So it's positive in quadrant 1 and quadrant 2. And that's it. And it said, what are the angles between 0 and 2 pi? So the answers then are 1 pi over 6 and 5 pi over 6. The 30-degree angle in 1 and 2, and you have your answers. Turn the page. I know these were challenging for some when we did the quiz, so let's make sure we know what we're doing here. An experiment in a wind tunnel generates cyclical waves, so they repeat over and over again with this data. Let V represent the wind speed. Can you write a sine function that describes the wave? So let's look at the y coordinates to understand it. This one starts at 14, 36, 58, back to 36, back to 14. So clearly 14 is the minimum. The middle of the wave is 36, and the top of the wave is 58. So already I know if the middle of the wave is 36, that's my k in my formula. Now, to find the amplitude, I'm going to subtract the top, subtract the bottom, and divide by 2. So 58 subtract 14. I should be able to do that in my head. I'm not thinking right now. So 58 subtract 14, and then divide by 2 is 22. So the amplitude here is 22. Oh, we're going to write it in terms of let t represent the time in seconds. So let's write it right here. So f of t equals, as a function due at time, the amplitude is 22. Next I need to know is the period. How long does it take to go from the bottom back to the bottom again? How many seconds did that take? So 14 back to 14 again. And it took 32 seconds, right? Yes, seconds, 32 seconds. So we're going to go 2 pi divided by 32. That's simple. Then we're going to go x. Now, here's the challenge. Sine has to start in the middle. So where is the middle? And at the middle, going up, starts 8 seconds in. So I have to shift this over 8 seconds for it to match this wave. And that's it. Oh, and this should be a t, not an x, because our variable is t. Let's try it again. So in this example, first of all, you have to do a scattergram, which is kind of fun. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for all the months. I'm going to look at the data. So it goes from 38 as my low up to 75. So I think what would be a good, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 75 divided by 9, that's going to give me a good idea. So like 8. So 8, 16, 24, 32, 30, 40, 48, 56, 62. Did I do it right? This here, 8. And then 8. That's close enough. So I'm going to do a scattergram with this. So at 46, at 51, 55, 60, 5 is 68, 7, 75, 8, 74, 9, 68, 10, 62, 11, 41, and then 12, 38. So this is not going to form a perfect wave in terms of what we're doing, but we need something that goes closely to model this. So to understand that, the minimum, and we can estimate the minimum. So you have 38 on one side as a minimum, 41, 46. So just take the lowest value, that's fine, 38. The top of the wave is at 75. And we can create a wave based on this. So I know the amplitude, I would subtract and divide by 2. So that's 37. So 75, take away 38, and divide it by 2. Yeah, 37, so it's 18.5. The middle of my wave is going to be by adding and dividing by 2. So that's going to be 56.5. And the last thing I need to know is the period of this function. How long does it take? And it's 1 year, so it's 12 months. And then we're done. So we're going to write an equation. Y equals, the amplitude is 18.5 sine the period, so we're going to go 2 pi over 12. Now the phase shift, so think where 6 months would be maximum, right in the middle of our wave, even though it's not quite the max, but it's close, right? 6 is in the middle. We start at 1. So where is the middle? Like, what do we divide by? These are my marks, right? And really, it's 1 month in, 2 months in, and so on. So think of it even like with 0. If you take 12 months and divide it by 4, every 3 months means something. So the beginning, the middle, and so on. So I'm going to have to subtract 3 so that it starts in the middle of my wave. Because I needed to start in the middle and then go up. That's what sine does. So I shift it over so it's the sine wave. All right, turn the page. Some more graphing. Number 52, can you graph tangent? Tangent does not have an amplitude. So the period's usually pi. Nothing changes it. It does have a point of inflection, and it's at 2. And then the negative helps me with direction. So tangent starts at a point of inflection, and then at pi will be another point of inflection, and then in between will be an asymptote. So I'm going to follow that pattern to begin with. It doesn't oscillate, so it just stays at that one height. Next, because it's negative, it would normally we'd go up to the right. So we'd find the middle, and from here we go up 1. But we're going to go down because of the negative, and then find the middle and go up 1, and it's going to go in that direction. So in the middle, go up 1, in the middle, go down 1, and then draw your cube function. And there's your tangent function. 53, can you graph cotangent? So the period would have been pi, but to undo what's inside, we're going to multiply times 2, so now it's 2 pi. The point of inflection stays at 0. And we have a negative 2, so that's going to change the direction a bit. So cotangent starts with an asymptote, and then at 2 pi is an asymptote. And then in the middle of that is our point of inflection, which is at 0. Negative 2, normally this would go up to the left, but this one's going to go down. So in the middle, we're going to go down to negative 2, and it's going to go in this direction because of that negative number in front. In the middle, go up 2, and then you have your pattern. And there's your graph. Secant. So for this one, there's no amplitude. The period stays at 2 pi, but it does have a phase shift at negative pi over 4. And we have an upper vertex at positive 1 and a lower vertex at the y value negative 1. So secant starts with an upper vertex. So at negative pi over 4, we're going to start at negative 1. So negative pi over 4 is in between these tick marks, and at negative 1. I'm going to count 2 pi to the right, and that's in between here. And again, it's going to be, negative 1. It starts with a upper vertex, which is at positive 1. So negative pi over 4, positive 1. Where's that white out? There it goes. So at negative pi over 4, positive 1, and then same spot at positive 1. Now, in the middle between those will be a low point. So there. In between here at negative 1, and then in between those will be asymptote. And there's your pattern. and then the lower ones fold down and the upper ones fold up. All right, turn the page. We're at our last page for the exam prep. 55, can you graph cosecant? So no amplitude. The period would be 2 pi, but to undo what's in there, I divide by 2, so now the period's pi. The upper vertex and the lower vertex. There's no phase shift. So cosecant starts with an asymptote, so that's there. And then at pi will be an asymptote. That's the end. And in the middle will be another asymptote. So it starts with 3 asymptotes. Cosecant's positive. So we're going to go to positive 3 and it folds up. And then in between go to negative 3 and it folds down. And there's your pattern. Done. All right, some inverse trig. Inverse cosine root 2 over 2. At what angle is the x-coordinate? Root 2 over 2. And it's 45 or pi over 4. Where's inverse tangent? Positive 1. So y divided by x. Which reference angle? Again, it's 45 or pi over 4. Inverse sine negative root 2 over 2. So for inverse sine, the y-coordinate root 2 over 2 is 45. But because inverse sine is negative, it's the negative angle that goes to quadrant 4. Inverse tangent, negative root 3. So again, it's going to be a negative angle in quadrant 4. I just need to know the reference angle. So if I go y over x, I'm looking for the y-coordinate to be root 3 for its work. So if the y-coordinate is that's 60 degrees. So it's negative 60 or negative pi over 3. Now we have some composites. We got to go inside, then outside. So inside, what's the angle for when the y-coordinate's 1/2? That's 30. And then what's the value of cosine at 30? And it's root 3 over 2. Again, inside to outside. So what's the angle for root 3 over 3 for tangent? Y over x. This time the y is 1 over root 3. So this is 30 again. And what's the value of secant at 30? Well, it's the reciprocal, right, of the x-coordinate, and then make it look right. And then here's the last one here. Again, inside to outside. So what's the value of sine at 7 pi over 6? So for that one, it's the y-coordinate. It's a 30-degree reference angle. And it's a quadrant 3, so it's negative. So what's the y-coordinate there? And it's 1/2. For inverse cosine, negative 1/2, this one's going to be found in quadrant number 2. The reference angle for 1/2 is actually 60 degrees. So this would actually be over 3. So the x-coordinate's 1/2. So it's a 60 degree in quadrant number 2. So it's 2 pi over 3. All right, last 2 questions. Can you solve the trig equation? So I need to get cosine by itself. So I'm going to subtract 3, and then I'm going to divide by 2. Notice the domain restriction. I need to know what quadrant we're in. So all students take calculus. If cosine's negative, it's not here or here. So the 2 quadrants the answer will be in is 2 and 3. If the x-coordinate is 1/2, then what's the reference angle? So that's a 60. And if that's a 60, then my answers have to be over 3. And in quadrant 2, it would be 2 pi over 3. And in quadrant 3, it would be 4 pi over 3. All right, last one. Get sine by itself. So step 1 is to divide by 4, and then the square root. Now, square root means the answer is going to be positive and negative, and the square root of 1 and the square root of 4 is 2, and it's positive and negative. That means it's all the quadrants. So all I need to know is the reference angle. So when the y-coordinate is 1/2, what's the reference angle? So it's 30 degrees. And then I just do every quadrant, because it's valid in every quadrant. So for 30 degrees, that's 1 pi over 6, 5 pi over 6, 7 pi over 6, and then the last angle is 11 pi over 6. Thank you. All right, Mr. G. Math, over and out.